Physics 2212, Lab 2, Charged Tapes. The purpose of this lab is to become familiar with the idea of charge on everyday objects and the interaction of objects' charges. Problem: how much excess charge is on one piece of charge clear tape? One piece of clear tape had an excess charge of 1.24 times 10 to the negative 7th coulombs. So some of the fundamental physics principles that we'll use in this lab are Coulomb's law, which is F electric equals K times Q1, Q2 over R squared. The definition of electric field is also used. Electric field is equal to KQ over R squared. Force on charges object F equals electric field times Q. The force of gravity on an object, which is F gravity, equals mass times gravity. Acceleration due to gravity, may I say. And then same charges repel and opposite charges attract. Experiment model. We start with a 0.2 meter base tape and put it sticky side down onto a desk. We then create a 0.2 meter U-tape and stick it almost all the way onto the base tape, leaving a handle for the grip. We quickly rip the U-tape off the base tape. You then put the U-tape aside and handle it as little as possible. Repeat steps 2 to 4. Hold your hand near one of the U-tapes. If the tape moves towards your hand, it is charged. Hold the two U-tapes near each other and observe their interaction. Hold a neutral object near a U-tape and observe their interaction. Rub a pin on a cotton cloth to give it a negative charge. Then hold it near the U-tape to determine its charge. Attach one of the U-tapes to an object at each end to hold it still. Hold the second U-tape parallel to the first U-tape and bring it closer to the first U-tape until it begins to float. Record the distance the tapes are from each other when the first U-tape begins to float. Assumptions. Each U-tape has the same net charge. Number 2, treat each U-tape as a single point charge. Treating each U-tape as a single point charge makes the calculations easier. Observations. The U-tapes repelled from each other, indicating they are like charges. The U-tapes were attracted to my negatively charged pin, indicating that they are both positively charged. The top tape began floating when the U-tapes were 0.027 meters apart. Constants. The length of the U-tape is 0.2 meters. The mass of the U-tape is 0.0002 kilograms. The distance between A and B, point A and B, are 0.033 meters. And acceleration due to gravity is 9.81 meters over second squared. Calculations. So the force of gravity on U-tape is you multiply the mass of the U-tape by the acceleration due to gravity, and you get negative 1.96 times 10 to the negative third newtons. The charge on the U-tape, use Coulomb's law to figure this out, and you derive Q from that, and you get 1.5408 times 10 to the negative 8 coulombs. Then we can find the number of deficient electrons by taking Q and dividing it by E, and that gives us 9.63 times 10 to the 10th as a ratio. These are Coulomb's symbols cancel out. Fraction of atoms that gave up electrons. So we know the number of atoms, we know the length of atoms, the length of tape, and we can use that to determine the ratio of electrons to atoms, and we get 2.4075 times 10 to the negative 7 electrons per atom. So here are the results again. Excess charge on tape is 1.54 times 10 to the negative 8th. Number of deficient electrons is 9.63 times 10 to the 10th. And the ratio of deficient electrons to atoms is 2.2 times 10 to the negative 7 electrons over atoms. So here's my coding representation. You can see that I plugged in the constants and then was able to determine the charge on the tape and the number of electrons on the tape. Okay, reflection. What if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tape and other charges objects? The tapes would still be the same charge, but they would still repel and float. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? Charged tapes have